Today's lesson is on symmetry and transformations. In this lesson, we'll be looking for lines of symmetry, figures that can be divided into mirror images by at least one line of symmetry is called reflective symmetry. If a mirror is placed upright along that line, the reflection of the mirror completes the figure. So here I have a regular triangle and a regular pentagon. I want to find how many lines of symmetry there are. So if I take the triangle and I divide it in half, you can see that the left side is a mirror image of the right side. They look exactly the same except for they're mirrored. So there's one, okay? And I can do the same thing with the pentagon, straight down the middle. And it's mirrored. Since these are regular polygons, I can find a line of symmetry through every single vertex of this shape. So that means there's a line of symmetry here on the triangle and one here. Okay, with the pentagon, there's a line here, one here, one here. This is a little bit harder to draw. And one here. I didn't get them exactly, but it's close enough. Because there are 5 lines. 1, 2, 3, 4, 5. That's kind of like a spider web. Okay. Here I have a regular quadrilateral and a regular hexagon. And again, want to find the lines of symmetry. Since they're both regular, I can find lines of symmetry through every vertex. So we're going to start with that. So there's 1 and 2 for that one, and through every vertex. So there, there, and there. Okay. But we also have lines of symmetry through the sides of these shapes. Okay. So that half and that half are the same, as well as those 2 halves. Okay. In all, we can find 4 lines of symmetry in the square and 6 lines of symmetry for the hexagon. Another type of symmetry is called rotational symmetry. And that means that if I turn a shape, it looks the same as its original orientation more than once during a full turn. Okay, so if I turn this triangle and I turn it, and now the A's down here, you can see it has the same shape as it started with. Okay, now that doesn't count if you go all the way and around a circle. Okay, so if we look at these letters, we want to see which one has rotational symmetry. So we're going to start with it, and we're going to start turning it. Okay, so if I start turning it, nothing looks the same so far. Okay, so I'm going to keep turning it. Okay, oh, and I can see that the H looks the same as it did at the beginning. Okay, let's keep turning it. Nope, nothing looks the same. I've gone all the way around. So the only shape, or the only letter that has rotational symmetry is the letter H. Okay, so on this grid, there's an L-shaped figure and its reflection. Is there a line of symmetry between the figure and its image? Okay. So I'm going to look at it, and if there is, in this case, there is a line of symmetry, because there you can see that this shape is mirrored. If you look at 3, you can see that each point is the same distance away from that line. That's 1 point away, 2 points away, etc. So it's reflected along the number 3. Okay, on this one, we've translated that L shape 4 units to the right. And then it asks, is there a line of symmetry? And in this case, no, because translation just moves a shape, to have a line of symmetry, there must be some kind of a reflection. Okay, so if I divide it here, these two sides are not reflected from each other, neither is it there. Okay. Now on this one, it says that does this shape have, the L is rotated 180 degrees, or half a turn around point A. The original figure and its image are combined to form one new shape. Does the new shape have rotational symmetry? Okay, so if I rotate it, if we look, and I rotate it, we can see that if I do half a turn, it looks the same as it did at the beginning. Okay, so I keep going. So yes, there is rotational symmetry. Hey, that's it for this lesson. Good luck on your homework.